To introduce myself, I work at NUS. I'm a researcher there. I deal with a lot of programming code and everything for simulation systems. But my interest is in big data. So for the last 5 months, I've been going to a lot of conferences in Singapore, Ahmedabad, in different countries as well. So I have found that there are a lot of problems which need to be tackled out. So today I'm going to talk about one specific problem which a lot of big data community is looking forward for, and maybe you can use this framework or the solution of this specific problem as a part of your competition challenge, because I'm thinking to compete on the same thing, right? It will just take me 2 minutes, so you can just fresh up for 2 minutes because I know it's a long day. Yep. Okay, so we'll just change the screen to so. Okay. So it's not screen. Screen resolution is changed. Screen resolution. So how many people are interested in knowing about the big data? Just raise your hands. Okay, so you know that there's a buzzword out there which talks about big data. And today I will be talking about the data cleaning technology, because when you process the data through a knowledge discovery process, there are a lot of steps involved in that. So the first step, the most important step, is to get the right data from the pool of big data set. So, and the second important point is, after cleaning, is to provide it for analytics software to process it very fast. So I'm not sure it's working. Okay. Yeah. Okay. Thank you. So this is the topic, and now we can go a bit more into. So before talking about the problem which we'll be tackling on today, I just wanted to share that this is not related to relational databases. We will not be talking about relational databases. We will be more focusing about the non-SQL portion. And okay, so when somebody asks me what is a big data, there are 4 things which I always talk about. First is the large volume, and in large volume we mean that multiple sources are coming. You use in your application point of view, you use a lot of sources for making the data large. There's a lot of cases. The second thing is the volume of data. The volume of data which is coming is very fast. It might be maybe 1 terabyte per second, and at that speed of data coming, your RDBMS structure fails out. The third thing is the high variety. High variety means that it might be structured, semi-structured, or unstructured data, so you don't know what you're dealing with, and from what source is coming from, it totally depends upon that. The veracity is that whenever your data is analyzed, or the result is coming, the business people don't care about that. They think so that it's not correct and everything. So because the visualization is not right. So in multiple data sources, we talk about data is coming from sensors, social, open data, a lot of other places which you can talk about. This is just a developer perspective, and you can use your own collected data as well in that. So yeah, after that, the rate of flow is very high, in which the RDBMS are expected to fail at this specific rate of the data flow inside that. I'll just show you an example. Just think about a traffic red light, right? In that there is a camera which is collecting a lot of high frequent images of the people who could see signal, something like that. So the information which is collecting is form of an image. So the image is actually very clear, it needs to be very clear, a high resolution. So that's a big amount of information. Now the flow of information is very rapid. Suppose, imagine 30 car strip in about 1 second. So you are having a big information which is coming up, right? And you need to do a real-time analytics. Personally, there's no real-time analytics. So the person cannot find out how many cars strip at that specific time. So he cannot give you a solution. So a nearby traffic police person cannot reach that place. So yeah. After that, we should move a bit more. Yeah. So when one needs to use the multiple sources, then he needs to make a lot of changes to the data, right? So, but the problem is that this data is totally in different formats. It may be XML, it may be a JSON file, it may be a CSV file, it may be text file. But the problem is that how do you ask your web application to use that data in one specific format? So there is no solution for that. Either you need to write your own libraries to convert that data, or you need a specific API provider to give you the XML or JSON, or maybe you can go to the open data side and you download the CSV file for the same. Now the problem is on the open data side, the data is in CSV format, but the data is not directly readable by your application. You need to convert it. It's not cleaned, it's not usable, it's not fit for your analytics. And the visualization is not possible for that. So yeah, let's understand this by example. Suppose I'm trying to develop an application in which I need to use two data sources. One data source is here, the data which is coming as a CSV file from your data.gov, right? And the other data source is maybe some coming from trend analysis of social media data, like from Twitter, so we are doing some sentiment analysis of that, so we need some trends on that. Now, I just go to the side of data.gov, right? And as you can see, I can see a lot of data. So there is a raw data category there posted on their website. This is not the Singapore version, this is just a global version. And that they have the interactive data sets as well as the raw data sets, right? So in interactive data sets, when you interactive data sets, they use the data, they create some very good visualizations, but these visualizations are only specific to their interests. Like for example, they put a very good interactive data set in which they told about that how many people come to White House. You know, it's not logical. Why would be somebody really interested other than the government? So they just invest a lot of money in that. But useful information which can be used by a lot of applications out there by developers is not fit for analytics. You know, it's actually not very fit. It's not transformed. So there is no solution out of that. So when we go on the raw data, I just take an example. As you can see, the U.S. overseas loans and grant. You can just see the page in which I think so some boring guy must have just filled up an HTML form, and he has just made an Excel sheet of the whole information collected according to his visualization interest and put it right here, as you can see, right? So you can see the error there. There's an XLS file. That's an Excel data. Now, the funny thing is that when you download this, it's created in a format which the manager may have approved to give it to you, but the developer doesn't want that information in that, right? So how do you tackle the problem? If you're an independent developer, you want the data which is required for your application to work in a specific format you want, right? But this information is coming totally rubbish. It's not useful for your using, right? So the solution which I would be talking about is actually creating a web platform in which you can feed in and fetch in all this data.gov or maybe the other open data institutes or other organization data, and you can see those data free of cost because they are public, so we can do it. It's not a big issue, and then you can do a lot of data cleaning right away. Transform that and you just produce an XML or maybe what if your architecture, if you're using a SOAP architecture, you can go for an XML. If you want to create a JSON file, then that can feed it up, and then you can give you can be given a security or a private or a public API call, and then you can present your thing, right? And there are some critical points in that. We will be using a lot of visualization. So there is a new technology which is coming in visualization. Visualization, nobody talks. In 5 conferences I've been to big data, nobody talks about visualization, but that's the most integral part, because you're doing a lot of processes and the boss never gives you the money for your work because he doesn't understand the specific process. So visualization is very integral part of this data, big data movement, right? So getting back to the definition which I talked about 2 minutes back, that what is big data? So there are 4 points which I was talking about. There is a large volume which we are always considering. The second is the velocity, that is the variety and veracity. Don't consider about variety and veracity, it's not important at this point. Just focus on the large volume and the velocity. So when we're talking about large volume and velocity, what do you make sense out of that? The sense is that your application should be doing the processing real time. You know, so that's why the whole distributed system comes into existence of using your Hadoop and other technology. So what the user expects is that you have an application, you get a real-time answer to your problem. You ask a question, you get a real-time answer. Now, just go on the back-end side. It's very difficult for the company to do that. But now what happens is, outside, there are a lot of companies which try to say that, you know, we have a solution. You know, you just download our green from Chorus software or some button box or something like that, and you can do the analytics very fast, but it's not very true. Because the analytic portion may be successful, but the other problem is they don't have the proper experts, they don't have the proper automated solution to clean the data real time and that too automatically. They just hire some data scientists, or they just hire some other guy, which they give them about this link of this website, and they download all the XLS files, and then the person does that manually. Just imagine how much pain it would be to do that. If there would be some solution in the market which can help those guys reduce the time, and maybe after, because we use a lot of artificial intelligence in that, and maybe sometime in future, it start understanding what other people use. So due to suggestions, we can create an automatic software solution which can clean and transform your data. So that's very fit ready for your application to do analytics. Now, what I want to say is, your application data is very fit, it's coming from the source, it's much more rich, and it makes much more sense, right? So when you do the analytic function on that, or maybe using your big data technology of Hadoop or something else, it processes very fast. So the result coming is very fast. Now, I was talking about an example of the traffic light, in which there's a camera, and on the camera it clicks a picture. Just imagine in 1 minute 30 people, they never expected 30 people will cross, but 30 people cross. Now there's one operator sitting there, and it's on a Sunday. Now if the software would be more intelligent to understand which person, it can analyze and tell you which person crossed and send him a speed ticket or something like that. Or maybe if there was an accident out of that 30 people, is one accident specific happened to that, they can ask a specific traffic operator to reach that place very immediately, right? But this is not done in real time. The situation happens, and then there's a thinking that it should be there and everything. But with this kind of technology, we can do that. But the problem in big data is there is a lot of components which are confused. In the market, people don't know what is happening, right? So the big companies, sorry to say, but it just makes a fool out of the whole public, right? Next thing is, so just sum up. Okay, so when we talk about social data, like this is the trends. We just pick up the trends according to the moods, or the sentiment analysis generally works like this, and then we just list out a big data set, we just feed it into a JSON file, and then we export it into our application, right? So whenever you are doing a process of creating an application which requires a lot of data, right? So you choose either social data or maybe open data. So you need to download the file and do every processing, and after that you can create maybe 15 or 16 sources. So you can add a lot of sources. There are a lot of sources available in the market, all right? Now once you're done with the sources, you can just proceed with the analytic portion and everything. So this is the problem statement. The problem statement is we have a huge volume of data which companies have been collecting for like 10 years or more, but they didn't knew 10 years back what to do with the data. They were just doing a mob understanding that someone is collecting, let's also collect something, right? But they don't know what to do. They didn't organize the way to save it very efficiently, right? The second thing is that now the people are very interested in sensors. So, because IBM is coming up with new software, a lot of other companies coming with new software, so they say the sensor, we can recall the sensor. The sensor market is also growing very high. So the term real-time data is also getting very hyped up. So when we talk about the data source, there are two types of data sources. One is the static one, which the company collects and gives you in a pile. That is what your data from the data.gov is there. The second one is your live data, the real-time data. It might be through a sensor, but it might be through internet or social media. The problem with the social or internet media is unstructured. You don't know, you cannot import directly into your online database and just manipulate that. But with the sensor is, you just get very little information. Like for example, if there is a device which can sense your proximity signal, then it just understands that, right? So it doesn't know much more information. So when it's a saying that if you have less information or the half information is more dangerous than having a full or wrong information, right? So that's the problem. The third thing is we have very good cloud computing setups. Now companies coming with AWS, like AWS is using instances and a lot of cloud computing power. So it's given a developers very good user platform to manipulate and do high performance computing. So there is the technology, there is the base of high performance computing out there, right? The third thing is there is a great analytics software. So we also have SPSS. There is a lot of companies like open source version. If you are a student, you can use Weka. So a lot of softwares are there for research-based analytics, for industrial level analytics, and the number is just growing very fast. But the visualization, there are very less tools available in the market. So if you are looking for the web-based development, then you just have few JavaScript libraries that offer you very good SVG manipulation. But else, mobile sector, a lot of good visualizations available, but not specifically for data. They are good for, if you write the whole graphics for that, then it's working. But if you just have a data, you just give it the data and the SVG knows how to make sense out of that, that kind of technology is very less, right? So what is missing is the data which is static. I'm not talking about the real time. The static data is totally in a variety of MIME types. So like, for example, one is a CSV, then is an R file, then is a different file, a text file, a different encoding or something. So the person who is getting the data has to do a lot of conversions, right? So this is a manual task. Even this is an automatic task. He needs to define some rules. So, but there is no software system to do that at the moment. So, okay. The second thing is that the data which you are looking forward from the web is standardized. Right, so the real-time data which is coming either from the sensor, they are using either a cloud module to fetch the data, save it on a server or something. So of course, real-time is XML or JSON. It's a web standard format. We can read that. There is a lot of libraries which can process it. But the static data has a lot of problems. The third thing is that the data is not in the post-query format. Now, what do you mean by post-query format? The analytics software guy, the software which analyzes all your data and makes sense out of that requires a specific format. This is the problem with a lot of companies because they say that if you give us Excel, then it should have this much structure, right? And if it gives you a result, it has to make sense out of it, right? So you need to give that a specific format. And the most important thing is that most of the organization just know how to use the analytics software. They just download the data, don't clean it, don't process it, just use the software to do some statistical analysis and something, and then just come up with the result, which is sometimes wrong. So that's a wrong notion that people use. Right, so wastage of computation in MIME types. So there is no automated solution, that's the problem, the first problem. The second is the wastage of time and effort in serializing to analytic software format. Every software requires a different format. There should be one standard format. And if you're a developer, it's very hard time to, if you're an independent developer, it's very hard time to convert these formats between, because they require a lot of computation power. If you're considering a 1 terabyte of data coming 1 second, you would require the same high performance architecture as it is required for computation analytics for that, right? So there's a lot of wastage of time, it's not necessary. The third thing is that less valuable information is there because, as I said, half information can be totally wrong. So it doesn't make sense. And the notion which a lot of companies started collected 10 years back was that you need to collect each and everything so that you don't miss out anything. Because if you miss out anything, then that you can lose a very important relation or something, and the information, the knowledge would not make sense, right? So that's the point. When you're processing it, you're not cleaning it, it makes the opposite. It works on the opposite case as well. If you have a lot of information which is not required according to your problem, you don't know what is the problem. Your problem statement fails out. So you don't have the right answer, and you will keep trying, and at the end you will end up doing nothing. Or maybe getting the result is 30 to 40% accurate, right? So this is a solution which I just thought about. It's not implemented, but because I will also be participating in this competition. So I just have one teammate because I work on the front end side. So the other teammate will be working on the back end side, and the analytics portion I will be doing by combination. If somebody is very interested to join up hands, we are also looking for some person who has good knowledge in understanding the R software, because we were thinking to do it something like an online R version or something that can do a lot of cleaning, right? It's a very efficient way of using open source software. So the solution is, help major data sources to convert their data into web standard format. So we just are very focused on just data.gov.ht because data.gov is not big. .ht is also too big. We'll just start with a prototype, one specific example, one specific category, and we'll just fetch the data. How do we fetch that? There are a lot of ways to fetch that. You must have heard about a web crawler, right? So that's the technical behind that. So we fetch a lot of data out of that. There is direct hyperlinks available to that. Now when we fetch that, we need to have a very graphical user interactive interface. A web application with a very powerful GUI that can show you that the data is fetched. You can choose very accurately in that. And the second thing about that is you need to clean the data out of that. Because you need to clean the data right away. Now this is the catch. This is the main feature of the project which you're talking about. The first way is you need to import the values directly. We are thinking of using something like an API. Google API there is very good. BigQuery for non-SQL. For normal fusion tables are there. So these two, and spreadsheets, Google Spreadsheets API. So these are very good for representing your data the same way as is represented there, right? Now the second point is to manipulate this data. Now you will be thinking, why do we manipulate the data? I'll show you an example. Okay, this example is a prototype which was created by Stanford Visualization Group, and they call it the Data Wrangler. These people only created the D3 JavaScript library. So I can just show you the website before moving. So you can go on, you just write Data Wrangler. It's just a demonstration. It's not an industry level software. So they just have very sample databases to just play and show the capability of that. The second is labor migration. Now if you see out of the 3 different formats, this is the way most of the analytics software use. So the first way is tab delimited and different type of structuring of the data is there. So they provide that in 3 specific formats and in Wrangler. Right. So this is just like simply like a spreadsheet. You just don't see anything different. Now just focus on the data here. Right. Okay. Just try to focus on this data. Now in this data, you see that the first row and the second row has information. Now this is the format, maybe very bad than this, you'll get in this XLS file. Now the problem with this is not in relational format. Okay, we know that when you're processing a lot of volume of data, then it's very difficult to use an SQL approach. But come on, you need to convert it into a relational format. If you want to use it through a non-SQL approach, the difference between the SQL and non-SQL, just as a key point, is SQL divides vertically, while the non-SQL divides horizontally, because it maps each and everything to the HDFS, right? That's just a technical point. So you get the data in this format. Now just tell me, if somebody wants to ask you that reported crime, Alabama, you don't have a number, so this is a missing entry. This is one important portion which might be very useful, right? Now generally, how do we do that? We use some predictive analytics. We use something like machine learning to get the value. We will not get a number, but we will get something like a middle between, right? A number and yeah. So how do we convert this? This is a user interface in which one you suppose you select. Yeah. So you select one specific quantity or instance. Let's divide this thing into attribute and instance. So the attribute is the top thing. Like for example, you want to categorize a lot of data into 3 columns, then it's known as attribute, and the values is coming as instance. So here we took one instance. So Alabama is a key value, which if the person seeing on the who's performing the data cleaning task sees Alabama as an important value. So on the left side, you can see a lot of suggestions. So the software suggests you, that you should take this value, make it a new whole complete row, column, and then you can put this value and just copy it, and then make sense out of different things. And at the end, you just get 3 or 4 columns in which, after doing a lot of data cleaning operations, you just get 3 columns, which is very useful relational based format. Now this makes more sense because the data is more rich. The software can understand it more better. The second thing which we would be doing is, after giving the user an interface to clean that thing, it's in relational database, we will give the user the opportunity, according to the domain, according to the type of data, and according to running some tests in between to understand what is the statistical importance of that. We will give them predefined maybe 10 types of visualizations. So they can just fit in the visualization and they can play with that, or maybe show their boss or something like that, so you can directly use the visualization, because visualization is more interesting. Everybody wants to see something interactive, right? And for example, this visualization is representation, not the analytic representation, just the representation of the data of the time, arrival, delay of the airplanes at the specific airport. Alright, so these are the dates. So you can choose a specific date and then the number changes. So here you can manually change. In the platform which we'll make, that you can manually change, you can make it more interactive. So the good thing is that the visualization that we'll be using is D3. So D3 is a visualization platform in which if you just give it data, you don't give it much information, it makes sense out of it automatically. That's why it is mostly used visualization library for real-time analytic solutions, right? Okay. So yeah, so the first thing was to help to fetch the value. So the web application has now fetched the value. Now what it has fetched the value, it has to convert it into a specific web format after cleaning and after doing all the visualization and everything. So we can do that by using Python libraries. It's a very good example on the internet. You can use Python libraries to convert your CSV, R, or something like a specific format, maybe into tab deliverability, and then convert it into a JSON format. So JSON is very acceptable around the community of developers. They understand JSON, they love JSON, and maybe XML is a structured way, but they don't like it, right? And that's what you can do. And then you can just give it a key, a security license, a security ID, just give it a private or a public API. It's ready to go. And the other important feature which we'll be adding to this is, after the API is given up, you can real-time watch the, this would be the page of the API. Suppose you want to use the API, you didn't clean it. It means you go on the website or on our website and you found a lot of people who submitted and created some API, okay? And maybe there's an automated solution that did so. But they have a hard time understanding which data set to use. Like for example, there are about 5,000 data sets on data.gov. Now the problem is that we don't know what problem to solve. Right. So here what we'll do is, before giving an API as an output key, you'll see a visualization which would be standard in all the data sets according to a domain, according to a category, so that you can know what is happening real time in that data. Right. This is an interactive data set. This is just a visualization of a domestic energy consumption before the analytics portion. This is just data representing that, that's all, but this is interactive. So if you make some standard out of that, then it will make more sense. And then the user will know what problem to solve, right? Okay. So the data cleaning operations can be done using something similar to Wrangler, because Wrangler was just an idea to show people that there is a requirement of such a technology in this specific area, right? Okay. Okay, so this is a process which is showcasing the knowledge discovery process, in which first you get the data, you find the target data, then you pre-process it, then you transform it, then you do specific something like data analytics or data mining, and then you get the knowledge. So knowledge is of course very important, but from data to knowledge there's a lot of cycle. As you can see, the target data, pre-processed data, and transformed data has always to be done by an expert. It cannot be automated, but we can give the user much more acceptability, compatibility to do it very fast. And a non-expert, maybe a person who doesn't know anything about IT or something, is just very good in understanding numbers. If he has a very good graphical interface, then maybe he can just use and process it. This process takes the most computation time when dealing with real big data. So the whole picture is that when the processing will be done very fast, and there would be a lot of people doing that through an easier interface, and we have a very good application on that, then the processing time will drop, right? So it will be more real time. So maybe later on, maybe 4 or 5 years out of that, if this application has a lot of understanding and understands the characteristics of the users, how to use, what methodologies to use, we can learn from that, right? This is very much available. There are a lot of open libraries to learn even the user characteristics. And then we can just try to set up some rules. Okay, before coming, the user can also set up some rules that this data should always be treated like this. So even in future, that rules can be used to automatically process it. So the real-time analytics increases. So you have a result on visualization that is very much real-time, right? Okay. So this is how the framework works, but let's discuss. Okay, so there's this very specific thing, BigQuery, and there's another Fusion tables. These are two important APIs which we will be using. If somebody has an understanding of the same, then you can just call us, right?
What's the name of the Python libraries that converts from XML to JSON?
Essentially, there's something like Dig2. It's on GitHub. There are a lot of other things, but they don't convert it very good. There is a Dig2 open source. Yeah, DICT and numerics 2.
Okay.
It's just a name. I don't know, somebody created it very randomly, but it's an open source library in which you can just convert your thread. Okay, that's all for today. Anything you want to ask? Anything which is half a doubt or something?